Okay, so here we go. This is your topic 1.12 in your book, what I have sent to you for practice. In that one, the topic number is 1.12. Actually, that is energy. And then for 1.13, I will talk about energy resources. Right? I have discussed theory questions with you people, and then I will solve some of MCQs for you, and that after that, inshallah, you people will be very clear about the topic, and then you will have a test, inshallah. Okay,
Okay,
so this
test
question number
on
one,
this?
yeah, this energy problem,
Okay,
energy
fine.
topic. Okay, the diagram shows the energy stores in mobile cell phones and how the energy is transferred between the stores. Chemical energy is there, and then internal energy, and then kinetic energy, and then heat, and then sound. And here is something missing. So, first of all, definitely, what we have to see that what is being asked in the question. What describes how the chemical energy is transferred? So chemical energy is transferred into electrical energy, electromagnetic energy, mechanical work, or sound waves. So what is suitable for that one? I mean, when you will move, when you will check about the cell or electronic system, chemical energy of the battery is converted into electrical energy, right? So that is why its option A will be correct one. Electrical
So where
energy
does
is
the mechanical energy be used?
no. How chemical, how battery is going to move an object? Never ever until unless current is not produced.
Oh, okay, I get it.
Okay, so batteries are used to convert chemical to electrical, and then electrical can be used for anything. For example, in your heaters, it can be used as a heat energy. In your uh, light bulbs, it can be used in the light energy. In motors, it can be converted into mechanical energy, and so on. Okay. The next one is
Yes.
mm, which row about the change of energy in the energy stores must be correct. Process, energy store, and change of energy is given to you. So, the first of all, if you see what form of energy is given to you, process is water pump up to a high altitude. So, it is a hydroelectric power plant mechanism. Energy stored is gravitational potential energy, and change of energy is in store increases. Okay, this is option A. I will just go through all the options and then I will come to the point. Then uh, water pump up to a high altitude dam, kinetic energy of the water it decreases. Air passes through a wind turbine, gravitational potential energy of the air increases. So it is absolutely incorrect. So just cross it. Air passes through a wind turbine, kinetic energy of the air, and it increases. So these are three very close options, right? Because all of these three options are not exactly wrong. So what we will do then, the change in energy, the clues are there in your question, that the change of energy in the energy store is to be taken, to be considered. So when you are going to use an energy, is it decreases or increases?
It
Just give me one point.
decreases.
Decreases, right? That's why when it is said that water pumps up to a high altitude dam, and gravitational potential energy of the energy stored is gravitational potential energy, and change of energy in store, what happens to that? When you pump up the water at high altitude, is it decreased or increased? Height increases, so what happens to the energy? It must increase now.
Yes, sir.
Yes, so that is why option A is most suitable for that. Here, water pump up. If it is not up, then definitely the kinetic energy. And when kinetic energy decreases, what happens? it is converted into mechanical energy. So that we can select that one, but here is option A correct. Then the next one is when I will go to the calculation part, then I will let you know about calculation. Here, you know, mostly the theory part, are, I mean, the questions like descriptive questions, non-calculative questions, they create problem for the student. So the equation used to find the change in gravitational potential energy of an object can be written as E delta EP, yani change in gravitational potential energy is equals to Y into Z into delta H. So where EPE is the change in gravitational potential energy and delta H is the change in height. So what is Y and what is Z? Isn't it? Do you think that for gravitational potential energy, what formula do we have? GPE is equals to what? If you know the formula, you can handle it very easily because mass and G are not changed. So when you go to GPE, change in DPE, it is M, G, and delta H. That's why your X is M and Z is G. Okay, gravitational field strength. Okay, so that's why option A is correct.
I get it.
Next one is an object falls down towards the Earth's surface. Towards, this is the key over here. Towards the Earth's surface. And what happens to the gravitational potential energy and kinetic energy of the object? So when an object is dropped, its gravitational potential energy decreases and its kinetic energy increases. So that is why when an object is dropped from the height, it hits the ground with very high speed. That's why the if the object is breakable, then they broke. So gravitational potential energy decreases because height decreases, and kinetic increases because loss in gravitation is equal to gain in kinetic. Right? So option B is correct one. Is it clear to you?
Yes, sir.
Okay, then which form of the energy is stored in the stretching spring? Chemical,
Mm,
gravitational, elastic potential, or thermal?
Elastic potential.
Elastic potential. Yes, exactly. So this is a fact. So you have to know about that. Brakes are used to slow down the moving car. Into which form of energy is most of the kinetic energy is converted in the car slows down? So it is not chemical. It is not elastic. It is not sound. Sound is there, but it is very small. Most of them is thermal energy because when we apply a lot of brakes, the tires and the brakes are heated up. Okay, so that is why it is thermal energy. Then question number 7: a tennis ball is dropped from the position 1. It falls vertically into the hard surface. Check this one out. Hard surface. Its shape is also changed, right? To position number 2. Which energy change have taken place between position 1 and position 2? So here it has all GPE. So definitely when that all GPE is changed, its kinetic energy is increased. When kinetic energy is increased, you must know that its kinetic energy is converted back to elastic potential energy because the ball has been reshaped. That's why its option B is correct.
Uh-huh. Got it, sir.
Okay, these all are actually the energy change questions, right? Here from question number 13, I have some calculative parts. That's why I have just given you the idea about energy changes, and then here we will go to the calculations. It is said
Sir,
that yes,
as far as I know, like there are questions in this chapter. Are they like the questions that you have to form an equation in them, right? And then solve them.
yes, yes. That's why I just brought you right here in the equatorial, equation problems, the numerical problems. Okay.
Oh, okay.
So, though descriptive questions are there also, those are related to energy change. What we have studied first in first 8 questions, they were basically energy change questions. These are calculation questions. So, in this question, a horizontal surface horizontal force pulls the block along the horizontal surface. The block gains 30 joules of kinetic energy in and 10 joules of thermal energy is produced by the friction between the box and the surface. How much work is done by the force? It's a difficult question for you people, because when you are talking about that, when a block is pulled on the surface, it gains 30 joule of kinetic energy. It gains 30 joule of kinetic energy, and 10 joule of thermal energy is produced as a friction. It means that uh, the work done by applied force, I have a small space, but I will try to manage that. Applied force is equals to gain in kinetic energy, gain in Ke, plus work done against friction, isn't it? Do you agree?
Yes.
So there is 30 joule of kinetic energy you got, and then 10 joule of thermal energy is produced. It means thermal energy has no other source, but some of the applied force or some of the applied energy has been wasted, right? So this is basically wasted energy. Okay, 10 joules, and this is the useful output. So what is the total input then? Total input is 30 plus 10, which is equals to 40 joules.
Oh, so
Is
we
it
were supposed to find the input.
input? Input, actually, we are doing something. Uh, we are doing um, something against friction. Okay,
Okay.
right? That's why uh, when when we are doing something against friction, some of the energy is wasted. That is the wasted energy, and 30 joule is useful. So when we talk about the energy, let me solve here. That is input energy. Input energy is equals to useful work done or useful energy plus wasted energy. Right? Are you getting it?
Okay.
So useful is 30 joule and wasted is 10 joule. It means what did you totally provided? 10 plus 13. Got it?
Uh, yeah, got it, sir.
Okay. The next question, question number 14. On this page, all of the questions are equation based and numerical questions. An object of mass 4.5 kg is traveling at a speed of 7 meter per second. How much kinetic energy does that object has? So how will you solve that? It will be 1 by 2 mv square. Do you have a calculator?
Yes, sir.
Okay, 4.5 is the mass and 7 is the speed. So 7 is square into 1 by 2. So what will be your answer?
And 7.5 into, no, 4.5. 4.5 into 7 square. 110.25. So C,
Yes, that's why option is C, 110.
10.25.
Got it?
Yes, sir.
Okay. Next is question number 15. That is a machine is very efficient. Machine is very efficient. What does it mean? It produces a large amount of power. It uses very little energy. It takes very little energy. Sorry, it wastes very little energy. It works very quickly. So which option is correct?
It's very
Efficiency means
efficient. So it's E. No, it wastes less energy.
yes, sure. It wastes very small amount of energy. It uses all what you gave it in a useful output. Then a force F is acting on a body to move at a distance d in the direction of force. Which action gives the power done? Yes, hurry up. In 1 second.
A.
Yes, well done. Then question number 17. An object falls from the top of the building that is 25-meter high. Air resistance is negligible. This is a key lifeline for this question, right? Because when you will consider the air resistance is negligible, then your all of the lost energy is converted into kinetic energy. So, what is the speed of the object when it hits the ground? So, this question is somehow hard for the students because we must know that loss in gravitation is equal to gain in kinetic, right? So, loss in GPE, is that signal visible to you? Is equals to
Yes, sir.
gain in KE. So loss in GPE is mgh and gain in kinetic energy is 1 by 2 mv square, right? Is it clear to you?
Yes, sir.
Okay. So just simplify the concept here. Mass and mass is gone and you need velocity. So this 2 will be shifted on that side. So it will be 2gh is equals to v square. Just plug in the values and your V will be equals to 2 into value of G into H and its square root, and it is 2 into 9.8 times how much height? 25-meter height. Just put all the values and give me the answer.
Um,
Yes.
okay. Second 2 into 9.8 into. So it is 2 into 9.8 into
9.8 into 25.
25. Okay. It's 22.1. So B.
दरवाजा बंद करके जाना. Nice. आंसर बताओ शाबाश.
22.1. So B.
22.1. So it is option B. Option B is correct. Okay.
Okay, yeah, got it.
So these type of questions are some tough questions. So I believe that now it will be very clear to you. It is 22.1. So that's why I selected that option. Then a crane takes 2 minutes to lift a load to the top of a building. The change in the gravitational potential energy of the load is 360 kilojoule. What is the useful output of the crane? Right. So how we will solve that question? This is your question number. This is your question number 18 in the form. It takes 2 minutes. Time is given to you. This is 2 minutes, so you can convert it into into seconds. So it is 120 seconds. Then gravitational potential energies of the load is this one. This is its GPE. Okay, 360. And what will be the power? We are supposed to calculate the power, na? So power, what will be the formula of power? Power is equals to energy divided by time. So here energy is GPE divided by time taken. So it is mgh divided by time. Time is how much? 120 seconds. Just put the values. Mass is sorry, the total energy is given to you. Instead of this formula or instead of this step, just put the values directly. Okay, and that is your 360 kilojoule. 360 kilojoule is basically 1000 divided by 120. What will be your answer? Your answer will be 3000. So it is 3 kilowatt. I think so.
3 kilowatt. Okay,
Yes,
let's check.
3.0 kilowatt. That is the answer. Okay.
Yes, sir, got it.
Then next is very simple to you. Simple for you. An object is in free fall. Change in gravitational potential energy of the body depends upon mass, depends upon change in height, and gravitational phase run. What is the correct expression? Yes, hurry up.
A.
Very good. Last question for your calculation, then I will switch to the topic. Uh, Transfer of energy. Yes, a car of mass 1500 gram has a speed of 20 meter. It accelerates until its speed is 25 meters per second. What is the increase in kinetic energy of the car? Mass is given to you, speed is given to you, initial
Mm,
speed, it is your initial speed, it is your final speed, and what is the increase in kinetic energy of the car? So we have to find change in kinetic energy. So this was a good question. Change in kinetic energy, that is equals to 1 by 2 m v square minus 1 by 2 m u square. So 1 by 2 m, that can be taken as common. V square minus u square will be plugged in. Just 1 by 2. What is mass? 1500 kg. And what is final speed? 25 square minus 20 square. Never do 20 minus 25, sorry, 25 minus 20 square. That is absolutely incorrect. 25 minus 20 square, that is wrong. Don't do that. Okay, yes, let me know the values.
okay, sir. 225 square minus 20 square. Sir, it's
Yes, what is the answer?
no wait. I messed something up. Wait. Just a second. 1500. So yeah, it's 170 kilojoules. So see.
Answer आया?
Yes, sir.
Yes, what is answer?
170 kilojoule.
Good. Is it clear to you?
Yes, sir.
Okay. Okay. I'm searching for efficiency question actually for just because I have not solved efficiency questions for you. So I will solve some of the efficiency questions. I will search them out. Hmm. Yeah, this is that question. A motor is used to lift a load of 40 Newton. Lift a load of 40 Newton. The power of the motor is 40 watts and the system is 20% efficient. How long does it take for the motor to lift the load of 0.5 meter? So actually, what do we need or what examiner wants from us? This is
The
basically
time.
force. Mhm. Or you can say this is actually the weight rather than force. You can write it weight. Okay. Then the motor is lifting that load in the upward direction. This is the total height which it is lifted. And what is the power of the motor? Motor is of 40 watt. So this is your input power, and this 20% is your efficiency. What is that 20%? It is your efficiency. So you use that formula, that efficiency is equals to useful output divided by total input times 100. Okay. What is useful output? Because motor is lifting and it is working in terms of gravitational potential energy. That is why it is mgh. And what is total input? It is 40 watt. So remember one thing, as I told you, that if you are using output as power, then input must be in power. And if input is in power, output must be in power. So what about this? Isn't it energy or power? Mgh is energy, na? And what about
Yes,
40
sir.
watt? 40 watt is actually power. So for these type of questions, what do? You have a choice. Either use this in form of energy. So 40 watt will be multiplied by time, because what is the formula for power and energy? Power is equals to energy divided by time. And from here, what is energy? Energy is equals to power into time. So what is power actually? 40 watt. And how much time does it need? We do not know that. So I will just use it as t. What will I do? I will just use it as t. Oh, what happened? Hmm? Everything is whitewashed. Come on. No, it is erased. So sorry. I will just do it again. I was talking about that efficiency is what? Useful output energy. Useful output. Yes, energy. Or you can simply say,
Oh my
let me,
God.
yeah. Do you have a question?
No, sir.
Okay. So I was just talking about that efficiency is equals to useful output power divided by total input power. Total input power times 100. Okay. So what is efficiency here? Efficiency is 20%. What is useful output power? As I told you, that energy is mgh, because this is the output energy. But when I convert energy into power, energy divided by time, that is equals to power. So I will say that power output power is equals to mgh divided by t. I will use that formula as a useful output. So 20 is equals to mgh divided by t divided by 40 watts, right? Because input power is 40 watt. Just cross multiply that, it will become your 800, and that is your mgh divided by t. From here, your t will be shifted on that side. T will be equals to mgh divided by 800, and your answer will be, what is m? Are you there?
Oh, yes, sir. My mic was muted.
Okay.
500
Okay.
kg.
Okay, M and G are collectively, this weight is collectively 40. Height is how much? 0.5 meter. 0.5 meter. and divided
Uh-huh.
by 800. So this is basically efficiency. So I have to multiply every step by 100, by 100, by 100. So just please calculate it for me.
Okay, sir. To 0.5 by 200. 2.5.
Is it clear to you? That's
Yes.
why I was
It is.
wondering for MCQs of efficiency, so that they are actually the hardest questions of your work energy power chapter.
Uh-huh. Sir, they're long though.
Hmm?
They're long, like they're really long than the.
Yes, they are. They are. As I told you, that efficiency questions are the tough questions. Okay, go to that one. Question number 34, and then question number because question number 34 has a new concept, right? A
Question
spoon of
number
mass m
34.
held at rest in water. Held at rest in water. Okay, when it is at rest, its kinetic energy is zero, isn't it? Rest means zero velocity. Velocity is zero, so that kinetic energy is zero. Okay, the stone is released and falls vertical distance h. When stone is released in the water, it goes down. The stone reaches with velocity v. Some of the original energy of the stone is transferred to the water as it falls. Resistive forces cause the temperature of the water and the stone to increase. So it means some of the energy has been wasted in the thermal. Which expression gives the work done against the resistive force? Wow, what a question. Now I will just make a concept clear about this one. This is the stone. It was at the surface of the water. Here it has all of its mgh, right? Which energy does it have? Its all energy is mgh. And when
Sure, but
it uh bolo.
GH is when it is on the, like, is it on the floor right now?
No, 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 no. It is at a height from this deck. This is the deck
Oh,
of the water.
okay. Okay,
Okay,
then I
so
get it.
its kinetic energy is zero here. So when it will start moving down, it will get kinetic energy, right? So for example, when the stone just hits the floor or before, because he is asking that at certain time, let's say this is a stone, and at this time its velocity is v. What is the velocity of this stone? V. So definitely if it has velocity v, it will have kinetic energy, which is equals to 1 by 2 mv square. And what about the statement? It is said that water and stone both has increased in temperature. It means it has loss in energy, right? Or rather than writing loss in energy, you can say thermal energy, right? What is that? Thermal energy. So what is this thermal energy? Isn't it work done against friction? Can I say that is work done against friction? Because when you are working against friction, as I asked you in that question of brakes, when you apply the brakes, why the brakes are getting hard? Why they get warm?
When they get warm, they release out thermal energy.
Because there is a work done against friction. When we apply the brakes, actually we work against friction, and due to that, heat energy is being produced,
Mm-hmm.
right? So
Yes, sir.
if I keep this concept here. So, sorry, loss in GPE equals to gain in KE plus work done against friction. Work done against friction. Are you getting it?
Oh, yes,
Because
sir.
these are the two games. Na? So work done against friction will be what? That will be equals to, this equation will be equals to mgh. This will be shifted on the left side and it will be minus 1 by 2 mv square. This is the question. Question of the lecture. Got it?
Kind of. Yeah.
Just review that. Inshallah, you will get it.
So why are we subtracting again?
Because I need work done against friction. Okay, let me make another equation for you. The equation was mgh equals to equals to 1 by 2 mv square plus x, because x was that thing which was required. So from here, if I want to calculate x, but this is work done against friction, so should I not shift this on the right left side?
Hmm.
Isn't it now?
Oh,
ऐसे ही होगा ना?
yep. I get it.
Yes. That is the problem. Okay, okay, okay. Now I have 10 more minutes and then I will switch to the energy transfer questions. I hope that, yeah, one more question which is here, question number 48. These are the tough questions, descriptive ones. That an object on a thread is swinging between y and z, x, y, and z. Sorry, x and z. The motion and sorry, it is momentarily at rest for x and z. It means here your kinetic energy is zero, right? Again, here your kinetic energy is zero. Okay, an incomplete word equation about the energy of the object is shown below. That gravitational potential energy is equal to kinetic plus dash energy plus energy loss. So gravitational potential energy is equals to kinetic energy plus dash energy. Sorry. That is in this way. Gravitational potential energy at x. Here, all of the energy is GPE. GPE at x, because this is complete one equation. I just ignored that. This is the gravitational potential energy at x is equals to kinetic energy at y. Kinetic energy at y plus what? Dash energy at y. Kinetic energy at y plus potential energy at y, okay, plus energy loss, because it has some height, okay. Are you getting it?
Yes.
Because it has some height as well as it moves. So that is why you can write that GPE at y. And if that is a stretchable cord, right, then we can say that elastic potential energy as well. Elastic potential energy as well. In different cases, the questions are different. So one of them can be written in this way. And yes. Here is the transfer of energy resources. In energy resources, Yes, question number one is calculated. The woman mass is 50 kg and has an 81 joule of kinetic energy. What is her speed? So her speed is, you can use that formula that Ke equals 1 by 2 mv square. And from here you can calculate V. I believe that it would be easy for you. That's why I'm just going to skip and move on. A bicycle braking system transfer energy from kinetic energy stored in the bike to an internal energy stored in the motor, converts the energy from chemical energy stored in the battery to the kinetic energy stored. Okay, what enables these energy transfers? Right, braking system. What force is there, or what energy is there? Mechanical work done is there, and in motor, electrical work done is there. That's why your option D will be correct. पानी
Mm,
यानी ब्रेकिंग सिस्टम इलेक्ट्रिकल तो नहीं काम करता ना. Does it work?
no.
So we need mechanical work and electrical work. Motor के ऊपर mechanical नहीं करता, so electrical works. Okay.
Uh-huh. Got it.
Okay. Then next one is research is being carried out to produce the electrical energy from the fusion of the hydrogen in nuclei, which row stores two of the problems designing in the fusion reactors. So in fusion reactors, you need temperature needed is very high because fusion will take place. And why obtaining a high density of hydrogen nuclei is difficult? Because at this much high temperature, density of the molecules decreased, right? So low is not there, very high, the nuclei are negatively charged and repel each other. No, nuclei are positively charged and repel each other because at this much high temperature, what will happen to them? They will be ionized. Okay, is it clear to you?
Um, okay. Like, so how would they be ionized again?
Actually, when temperature increases, the electrons in the shells of the hydrogen, they escape. As a result, only protons are there.
Oh,
Okay, when electron is lost, आगे आप लोग पढ़ोगे जाके, electrons lost, so remaining it has positive charge, and that positive charge is basically what?
protons.
Ion, proton. Okay, is it clear to you?
Yes, sir.
Okay, then a mass is lifted from rest, no kinetic energy at all. When it is lifted from rest, um, energy of the mass, Q is the kinetic energy of the mass at Y, which expression gives an equal mechanical work done by the mass. So here it has Q is having kinetic energy of Y over here. So it means work done is kinetic energy plus potential energy. Okay, is it clear to you?
Yes, sir.
So Q is kinetic energy. So just put Q here, and potential energy is what is potential energy? P is the increasing gravitational potential energy. So it is P plus Q. So option A is correct. Okay. So these are again calculation questions. So I believe that you will be able to handle these questions right now. Go to that question. A box of mass M slides down the slope of the length against frictional force. Against frictional force, right? It depends. It descends vertical height d. As the box slides down the slope, the loss in gravitational potential energy and it does work against friction. Which row gives the loss in gravitational potential energy and the work done against friction? So loss in gravitational potential energy is basically due to this height. So you will say it is mg into d because that d will work as height. And work done against friction is basically along this is right. So that's why you will say F times L is basically the work done because F into D is there. Na? So that is just the trick in this question. So loss in gravitational potential energy is mgd and work done against friction is FL. Right? Is it clear to you?
Yes, sir.
Okay, yes. This is the last question I wanted to discuss with you. Question is related to a bungee jumper that is attached with an elastic cord, jumps from the platform and falls 60 meters before starting to rise. 60 meters before starting to rise again. The length of the unextended length is 30 centimeters. At 30 centimeters, it has no extension. So it means till that point, elastic potential energy is zero. What it? In which position is the elastic potential energy and kinetic energy present? It is at rest. So kinetic zero and EPE zero. Here it is moving downward. So kinetic is not zero, but elastic potential is zero, right?
So how would we determine if the elastic potential is zero or not?
Because it is said that it is not stretched before unstretched is 30 meter. What is unstretched? It is 30 meter. So beyond 30 meter, it will stretch. So at this point, elastic potential energy is there and definitely it is moving downward. So kinetic energy is also there. So that's why option C is correct.
Then why don't we get do D then?
Yeah, at D, it is stretched to a maximum point, right? And from here, it will start its reverse motion. It means here it will stop. So again, its kinetic energy goes to zero.
Uh,
देखो बंजी जंपर को इमेजिन करो ना, he will jump and go and go and go and then finally elastic cord will start stretching and then it will going down. That is point C. And finally when elastic cord has its elasticity is finished out, it would stop for a while and then it will move back.
oh, okay, yeah, got it.
Got it?
Yes, sir.
Okay. So this was a a valuable class for you. I believe that. So just go through rest of the questions. I will try to send these for you there as well. So I believe that the things are in your control now. Okay. See you then, inshallah.
Okay, sir.
Okay. और प्लीज काम कर लेना ठीक है.
हाँ काम मैं कर दूंगी promise.
प्रॉमिस किया हुआ तूने. अल्लाह हाफिज.
Yeah. Lafis.
ठीक है. हमारा प्रॉमिस मैंने रिकॉर्ड नहीं